And hello, welcome to this video. We're gonna talk about OPCUA implementation in Python. So I'm running it this time on Manjaro Linux rather than Windows, because OPCUA Python is pretty much a cross-platform kind of a thing. And as usual, if you want to install it, just do pip install async UA. Okay. And then it will say, yeah, the thing's already installed. So, regardless of what kind of platform you are on, I mean, if it's a Windows platform, you use the same command. If it's a Python, if it's a Linux platform, you do the same thing as well. Okay, so first thing first, let's briefly go through what we did last time. We actually went through a server minimal and a client minimal Python Python files. So now to start learning and exploring a little bit more, we just got to jump right in, okay, and tinker with the server minimal.py to see what actually happens. Okay, so let's take a look at server minimal.py. We'll do a vim, and just to refresh your memory. That means, just doing text editor. So remember, all these parts here are importing. And then we actually define a new function or OPCUA method. And then this thing here, async def main, all of this here is the main OPCUA server loop. And like I explained in the last video, the only thing this loop is doing is to define. Okay, the thing that this loop is doing first is to, there are loggers going on. Loggers give you debug information. So if you don't want to do debug information, you don't need to. All right. Okay, the next thing is to set up the server. Okay, so server is an object. Okay, this server here is a class, and this class is actually from async UA import. We initiate the server, we give this server a URL. Okay, so I'm not going to explain this part. Okay, so there's a namespace thing. Again, not really sure, don't worry. If you're not really sure, don't worry. Just look at these two parts. These two parts are crucial to the code. So my object equals to, await server nodes add object. So you're declaring a new object in the node, and you're adding a new variable to the object. So there is some sort of hierarchy here. So nodes will contain objects, and then objects will contain like variables. Okay, so okay, if you're not sure what nodes are, I'm also not that clear at this moment at the time of making this video, but my conception of it based on what we are exploring is okay. We have objects is a very object-oriented programming concept. If you learn Python itself, generic Python, you should be able to know what objects are. So objects, within objects you have attributes and functions. Okay, I should get myself a mouse. Let me go get a mouse first. Okay, so yeah, I paused the recording and then basically got a mouse. But okay, to you it seems like a fast forward, so I just magically got my mouse. Okay, whatever. So objects, usually what do they have? They have methods or functions, FUNC, functions, and then they what else do they have? They also have attributes, or attributes, right? So ATTR, I'm gonna call it ATTR. Okay, so OPCUA, I guess, extends this by having some variables here as well. They call this whenever you have a variable, you just call it a variable, which is another kind of object or class or whatever, but it's a way for us to store data. So for example, temperature of something, or pressure, or flow rate, or whatever, depends on what you are trying to control. Okay, so all of these are, you group them under objects. But let's say you have a huge OPCUA server, right? And then you have many objects. You have object 1, object 2, okay, all the way up to object 100 plus I don't know how many, right? So you kind of want to group them together, similar objects together. So I guess you group objects together under the nodes. At least functionally, to me, this is how you sort of classify what's the difference between nodes and objects. And nodes are just a higher class of things, and of course, yeah. Let's see, where is it? Yeah, all right, it's here. Yes, so yeah, you see, nodes, objects. You have a node objects, then you have the object, and then under objects you can add variables as well. So nodes will be just one level below server. So you have maybe node 1, node 2, and then it's just ways of grouping many. This is just way of organizing our data. Each object will have functions, variables, attributes. You can group similar objects under one node, and then all the nodes will actually belong to the server. So I can't write server now because it's already out of the screen, but you get what I mean. Okay. So that's my idea of what nodes, objects, and variables are. So in case you're wondering, at least I see this is how you just organize data. So you create an object first, and under that object, of course, this object actually belongs. This object actually belongs to a node of some sort. Okay, so we'll deal with that part later. Then this object has this variable. Okay, and then it says the variable will be writable. And then over here, server nodes objects. Remember, each object you can actually add a method, or you can add a function. And this is what the function is. Okay, you can put all this data in later. I mean, we can deal with this part later. Then you can see this async with server while true. Okay, so this is the code to run while you are setting up or starting your server. Okay, yeah, so this is the code to do while you are starting up your server. So while true, you sleep for 1 second, async IO sleep for 1 second. Then the new value will be, okay, my variable get value of, you get the value of my variable, and then you plus 0.1. So what's the value of my variable? It starts at 6.7, and then when you do debug information, you can use the logger info, and then you have this await my variable write new value. Okay, so what's with all this async and what's with all this await? Well, we can try learning a little bit more by experimenting with this code. Okay, so my standard protocol is to always make a new file. Server experimental, you become experimental server. I mean, server minimal becomes an experimental server. We make a copy and then we rename it. Let's rename the experimental server.py. And then let's start tinkering with the code and learn things along the way. Okay, first thing first, yeah, one thing I want to get rid of, I want to make things simple, so I don't want to talk about methods first. So this add method thing I'll comment out using the hashtag or the pound sign. So I'm going to comment all of this out, and then of course we can see whether it runs. Okay, so let's exit. Okay, clear, and let me run a Python 3 file, and you can see here it's Python 3.10.2. Depends on what version of Linux or Windows you're running on. They may be slightly different, but this is definitely Python 3. Okay, and note that async QA is only available for Python 3.7 onwards, which should not be a problem for most of our servers. Just make sure you install the right version of Python. So Python 2 is not, you can't use it with async QA. Now let's try running this thing. How do we run it? Okay, the way to run this thing is to basically import first. So import experimental server. Okay, so we have to import experimental server, and then we need to run the main function. Okay, we actually have a main function, and it's an asynchronous function. All right, so if we type type main, Okay, it says main is not defined. So what's going on here? Why can't we just run main? Well, the main is actually part of this experimental server class or object or module. So you cannot just use type main. You need to do experimental server dot main. Okay, what does it say? It's a class. This class is called a coroutine. So asynchronous functions are also called coroutines. So you got to take note of that. That's what all this async here is for. We call it coroutines because we can run them alongside other code. But again, the nitty-gritty of this stuff, we don't go into it first. Let's just try running this thing. Okay, and how do you run a coroutines or asynchronous functions? Okay, we use the asyncio run function. So we can of course use the debug equals true or just leave this thing blank and see what happens. So we have to import the other module called asyncio, which is asynchronous input output. Async io.run. Okay, we can just do a run experimental server.main. So this is the function. You can of course have a debug equals to true, and then we will be able to see some outputs. Okay. Oh, I cannot do caps of true. Pardon me. Alright, so let me just give a normal true. And then the OPCUA server will start. It will take some time. And then it should do whatever the code is telling us to do. Okay. So it's executing tasks, pending task 1, all of that. And then okay, we don't see any we don't see any thing being printed out because I think I excluded this part of the code. This logging basic config level equals logging.debug. Alright, so I didn't include that, so it's not printing anything. So let me just try to print things manually. Okay, I'm not going to use the logger way. I'm going to try to print things manually. So remember the thing we are trying to print out is this my variable, right? We are trying to print out my variable because what happens here is that when we declare my variable, we use the await my object at variable, then we set a certain index to it. I don't know what, and then we give the name called my variable. Okay, makes sense. We give it an initial value of 6.7. How do I know what each of these things are? Well, to me, yeah, it's just guesswork because okay, index is actually this thing over here. Okay, my variable is a name, is actually a string which has a similar name as this, and 6.7 does make sense to be a good. It's just a float value. Okay, floating point value is a decimal number, which makes sense that you give my variable a decimal number value. Okay, so that's the initial value of my variable, and then the new over here you get new value equals to my variable get value plus 0.1. Then after that we write the new value of this new value variable into this new value thing over here. Okay, into my variable, sorry. So that's a right value. Okay, so we won't use the debug equals true, but instead I'm just going to start printing the value of my variable. Okay, so again we'll do things slowly. Okay, so let me explain again. So my variable is set with this index. I don't exactly know what it does right now. It sets this, it has this name my variable to it. It's a string attached to it, and the initial value, the value of my variable is set here at 6.7. Okay, so all this is not important. I actually commented it out. And also we set the variable to writable. I'm going to ignore all the awaits. Okay, so for the time being, of course. And then the first thing OPCUA does, this server does, is to sleep for 1 second. Okay, that's what the async IO sleep does. You can actually search it online to see what it is. Okay, async IO sleep. Okay, so this is coroutines and task. You can look at the sleep function. So it's literally sleeping. So sleep, it's a block for delay of how many seconds. So it's basically telling the Python code to wait. Okay, so you see here it's sleeping for 1 second. You can kind of guess the purpose of that. Okay, so the new value equals to await my variable get value, and at the first loop it's 6.7. Then we add 0.1 to it, and then we assign the value to new value, which becomes 6.8. And this one is just printing up some data, so I'll just ignore it. Okay, so await my variable write value, new value. So from this, you can guess that I'm writing the value of new variable to my new value to my variable. So the first loop, my variable will become instead of 6.7, it becomes 6.8. Then after that, this loop finishes, and then it starts all over again, and then you repeat the whole process. So this new value will be 6.8 plus 0.1, it becomes 6.9, then we keep assigning. So it will just keep increasing this value. So what I can do to sort of show that effect, okay, I can actually just do print my variable dot get value. Let's see whether this works. Okay, so I'm just printing my variable dot get value, and then of course I can print this as well. I can print okay, current value, my variable value is, okay, and then we just do that. Okay, so we get my variable, we'll go and get a value from that. Okay, so let's try running that. So I'll need to reload the thing again. Okay, reload experimental server. Of course, I'll need to save. Reload experimental server. Oh, from import library import reload. I'll need to reload experimental server. And then what do I need to do? I'll need to run the thing. Okay, experimental server.main, and we should be able to see some things print out correctly. So you see, current my variable value is, oh, now it just says a coroutine object node.read value. That's an object, right? Why isn't this thing get? Normally, get methods are supposed to get us the value of something, right? So if you get the value of my variable, you technically should be getting the number 6.8. Okay, why doesn't this thing run? Why doesn't this function run? Okay, reason is this, because when you actually start running something asynchronously, for example, you see asynchronous with server, okay, so await anything that has to do with your server, I guess you have to type this await keyword in order to run the function. So you see, await async IO sleep, okay, that's async IO. You run the sleep function, but to actually run the function, you have to type the await. Why? It's because you type this async keyword first, or rather we have this async keyword first, and then after we have the async keyword, then we'll need to use the await thing every time we run the thing. So instead of my variable get value, the correct way to do it is await my variable get value. Okay, so let's reload the thing again, and we'll run the main server. So you see, the first time we get is 6.8, then you get 6.9, or somewhere you kind of round it off, you get 6.9. Why is this value so excuse me? Why is this value sort of decreasing over time? Right? So of course it's increasing by 0.1 every time, or roughly 0.1. But you see there's the last decimal number sort of tail off slightly. Well, reason is that is because what do you call that? Yeah, reason is because when you add 1 in Python or any coding language, you're not exactly adding 1. you're adding, I guess, a number close to 1, but that number has limited decimal places and is represented using what do you call it? It's represented using, I think, zeros and ones. It's in this a bit notation, or rather it's in binary notation. So there will be some sort of round off error if you keep adding things like that. However, you can see this thing will probably take a while. You can see the last 2 decimal places only changes by a little bit, but like, you know, several decimal places up is still roughly the same. So I mean, if that's acceptable, that's acceptable. Otherwise, you need to do something else. Okay, so definitely I don't just want to get the value. I'm interested in typing or printing the type. I want to know what kind of variable or data this is. So I'm going to print the type of my variable dot get value. All right, so quit this. Let's reload experimental server and we run it again. Okay, so all I did now is to print the type. Okay, so you can see this is this class is called float. It's called a floating point number. Okay, floating point number Python. So I'm pretty sure you know this by now. And I think this is actually this float values are represented as 64-bit double precision value. So float versus double in Python. Okay, float versus double in Python. Okay, so it says here double is more precise than float. Okay, so this is important to note. You can see the number of decimal places. So that's why you have all this round off thing. Okay, so you see 32-bit is usually float precision. Double is literally double of the float precision. But yeah. Anyway, so you should know that. Okay, so of course you can change it to a double type, but I'm not really interested in doing that. I'll just leave the thing as it is. So as the thing runs, of course it will get more, the value will get bigger and bigger. And of course I don't need to sleep for 1 second. I can sleep for maybe 0.2, and this code will run very fast, right? Okay, so I reload the experimental server and I'll use the async io.run to actually run this thing. So you see now it starts running very quickly. So actually what have we sort of gathered by experimenting here? Okay, we know that to run asynchronous functions we need to use this await thing. We use this await async io sleep, then we actually just play around with the values. Okay, and also to make sure the function executes correctly, you also need to use await as long as you use this asynchronous keyword. Alright, so you see the awaits being used every time we have our server. For example, when we see server.init, we use the await. Everything to do with our server, we also, and any function or object used with our server, we kind of need to use the await function. Okay, so that's the thing for most. Of course, you'll see the object declaration here and the set endpoint here doesn't have the await function for some reason. We'll need to learn about that later on to see what is the difference. Okay. Okay, so we'll learn it as it is, but well, it is at least now we know what this part is doing. All right, we sort of pry apart and experiment with this. Now, of course, these objects and variables are already there. Okay, so I guess what's a good next exercise, right? What's a good next exercise? Good next exercise is to try to get a client to connect to this server, and maybe instead of the server printing out all this value, the client will get the value of my variable, and then after that, it should hopefully get these values. So instead of this is the server code, which actually helps you to get all the information, right? So this actually helps you get the information on your server, and then the client will talk to the server saying, hey, I want this information, can you give it to me? Right? So that's what the client code side will do. All right, so that's what we will try to do next time. Okay, so this video is very basic. It's just to get you acquainted with asynchronous objects, or the async IO object libraries, and of course we call them coroutines. That's the proper name for them, coroutines. Excuse me. And how do we then execute functions within the coroutine? We need to use await, the await keyword. So we define coroutines using async, and we run functions in coroutines using await. Okay, anything else in that? Okay, no need to worry so much. Okay, so next time we'll learn more, but I hope to finish this series of videos. Okay, but yeah. So we have something going on here, and we have all these values coming out now. Hopefully next time we can actually run some what do you call that? Run some code that says let's try grabbing data of this thing using OPC UA Python client. Okay, thanks for watching.